Welcome to ATMOS 5000 Day 6. Our objectives today are focusing in on Chapter 3, Sections 3.2 and 3.3, namely the First Law of Thermodynamics, comparing and contrasting enthalpy and sensible heat, and then introducing the Lagrangian and the Eulerian reference frames. The First Law of Thermodynamics Summary is provided in this diagram. When confronted with a problem that requires you to use the first law of thermodynamics, the most important thing to figure out is whether or not you want to use the extensive form or the intensive form of the first law of thermodynamics, and which form of the equation you actually use depends upon the variables that you have and the variables that you're given. So always keep in mind that you're trying to use the variables that you have and make your life as easy as possible along the way. Moving on to the comparison of the Lagrangian and the Eulerian reference frames. The Lagrangian reference frame is one that follows the motion of an individual parcel. So the position of the air parcel is constantly changing, and one of the things that a Lagrangian reference frame is really good for is it's really good at trying to understand how the physical processes in the atmosphere affect an individual air parcel. So for example, you can kind of imagine that the Lagrangian reference frame is kind of like being on a balloon that is at equilibrium, and it's floating around just following the air parcel along the way. And as you're floating along on this balloon, you can imagine that the sun is heating you up, or at nighttime you're cooling down. There might be a cloud that's forming in this air parcel that is releasing latent heat. All of these sorts of things can be happening to that air parcel, and in the Lagrangian reference frame, you can keep track of how those changes are impacting that air parcel over time. We can contrast that with the Eulerian reference frame, which is tracking the fluid properties at specific locations. We often look at this in terms of a gridded analysis, where on the left here we have a horizontal grid that has an atmospheric parameter on it, in this case maybe wind speed and wind direction, and we're looking at how the atmospheric properties are changing at an individual location over time. So you would pick one of these grid points and think about how the atmospheric processes are affecting at that one location. And so not only do you have, say, the radiative heating or radiative cooling or the latent heat release or storage, you also have advection of properties that you have to include in the Eulerian reference frame that you don't have to include in the Lagrangian reference frame.